Everyone can hear me. Okay, good. So, first of all, thank you very much for coming. For those of you who attended my talk last year, what's a polite way of putting it? Someone threw things at me, so just to make sure that the odds are even this year, if anyone should decide to throw things again this time, I am well prepared, and I am not afraid to use it. It will remain right there. So, let's get started. This talk is kind of a few different things wrapped in one. So first of all, it's kind of a bit of a story of how I built this little side project, and especially like a hacker conference like this, I'm sure there's loads of people here who are probably somewhat similar to me in that regard, in that we're hackers in the kind of traditional sense, in that we tinker with things, we break things, we build things, we make things. And the thing that I want to talk about is this little project that I started. It was kind of like 3.5 years ago now. And it was literally just like a little weekend project. I was tinkering around with some code, and I was like, hey, it'd be a really cool idea to build a product, to build this kind of piece of software. And over the years, that's evolved into essentially what is now a fully fledged company. I actually founded a company last year, took investment, and launched this as an actual commercial service. So this was like the little side project that eventually consumed like my whole life. And there's been some really kind of interesting things happen throughout that process. I want to spend a lot of time talking today about the technical challenges of building something like this and how we've actually scaled it. Some of the interesting things that you learn when you're building something and it just kind of accelerates beyond what you ever expected it to. And also some of the kind of the high scale things. You'll see towards the end what I'm talking about. But I want to start with the kind of introduction to explain what the product actually is, what this little project that I built did. And all modern browsers nowadays, literally every single mainstream browser has the ability to become a more active participant in delivering a browsing experience to your visitors. So traditionally speaking, like you have a website, someone opens their browser, they go to your site and you send them the page, and like that's kind of it, right? You send them the page and then they do whatever they want. Maybe click a link, fill out a form, send something along. But there's loads of different scenarios on the web and when things can go wrong. So someone might come to your page and they might see an error, something might break, something might happen that wasn't supposed to happen. And all of these browsers now have native reporting capabilities built into them. Now, most of them, and some of the ones that I'm going to talk about, are geared towards security. So if someone comes to your website, for example, most browsers now have an XSS auditor built into them. So if the browser detects what it thinks is a cross-site scripting attack against one of your users, rather than just like render that script and let the attack run against the user, the browser will now step in and say, this really looks like a cross-site scripting attack, so I'm just going to filter this out, which is really good. And they do this by default. But you as the website operator would never know that. And we should kind of know that, right? Like if you're sending a page to a user and the browser is filtering something out, changing something, taking some action to protect your user, you should probably know about that. So the browsers now have these reporting APIs built in, where you can say to them, look, here is my web page, and if something goes wrong on this web page, then please will you call back and tell me. Let me know that this thing broke. They saw a security warning. You disabled something to protect the user. Because all of these things happen, and they all happen now. Most mainstream browsers have these things enabled by default. So whether or not you know that they're there, they're already doing these things. And what we need to do is start getting the feedback from the browser. And that's what these reporting APIs allow. Now, the number one thing that we support is a particular feature called Content Security Policy. And Content Security Policy has been around for a really long time. We're currently on version 2 of CSP, looking at version 3 maybe this year, next year. And it's essentially a very simple whitelisting mechanism for content on your website. So you deliver your page out to the browser, you've got all the HTML content, these are the headers at the top. And you have things that we're probably already familiar with, things like the server header, the date header, content encoding, content type, cache control. You just set another response header called Content Security Policy. And this is how you deliver the policy to the browser. And the policy that you deliver to the browser controls what content is allowed to be on your site. So you might deliver a CSP that looks something like this. So I'm saying to the browser, by default, my website is allowed to load content from my own site. So you can load JavaScript from my domain. You can load images, styles, scripts, all of those things. But then you can get really specific with different types of content. And especially with the script source, this is where stuff starts getting really powerful. Because what you do is you say to the browser, look, this is the only location you're allowed to load JavaScript from. You load it from my website and from my JavaScript CDN. Don't load script from anywhere else. And this is how we can start combating some really common cross-site scripting vectors straight away. Because if someone manages to get a script tag into my page now, and it's trying to load script from evil.com, then the browser isn't going to load that because it'll look at the script tag, check the source attribute, and be like, right, evil.com, let's check the whitelist. Well, evil.com's not in the whitelist, so we're not going to load that script anymore. And we've already neutralized one pretty kind of common vector of cross-site scripting. The other one would be if someone just injected the script tag in line. So they didn't have a source attribute and fetch it, they actually just wrote the script tag into the page. When you enable CSP like this, the browser will automatically disable inline script because the browser has no way to know where that script came from and if you put that there or someone else put that there. So if it was genuine inline script, what you would do, you would take it, externalize it into a file, and then load the file back from your own domain, which would match on self. So you can still have your script and you might have to externalize a few snippets, but that gives the browser the information that it needs to know this is genuine script, we should run it. So this is what CSP does by default. You can have all the different types of content, not only what we call the fetch directives where you load stuff like script style images, you can also control where it can send stuff as well with things like the form action. And also you can control with the connect source stuff where like XHRs go. So you can actually control where the browser's allowed to send data. Because I know that all of the forms on my website should post back to me. I don't want my login form posting anywhere else. And the browser will enforce this and make sure none of these bad things happen. Now this is really good because now that we know none of these bad things will happen, but we actually don't know if they happen, right? If they happen, the browser will block them, but we don't know if that took place. And this is where you need to ask the browser to tell you using one of the reporting APIs in the browser. So if I say all forms on my website should post back to me, and then one tries to post to another origin, to somewhere else, the browser will send me a report back. And they actually post you a JSON payload. So as soon as something violates that policy, as soon as something happens that shouldn't have happened, the browser will open a connection to the endpoint you specified, and we specify this endpoint here at the bottom. Oops, there. So the report URI, this is where you tell the browser to send the reports, and this is the report that it sends. It's just a JSON payload. So you just have to have some endpoint somewhere to ingest this, and it has all of the information inside it of exactly what went wrong. So the browser says, I came to this page on your website, and something violated the script source directive, because you said scripts come from self and this CDN. It gives you the original policy for debugging so you can see what it was working with, and it says, and by the way, this is the file that I blocked. So I would now know on my home page, I have a script tag trying to load from evil.com/keylogger.js. And the browser will have blocked that to stop it from loading, but it also sends me the report so that I actually know this happened. So you can learn, it's literally real time. It takes like a second to post a JSON payload and ingest that on the other side. So as soon as I get reports like this, I can be like, wow, there's a keylogger on my homepage. There's a script tag that shouldn't be there. I don't know how it got there at this point, but I now have the information to go investigate that. So this is a really powerful mechanism. It's been around for a few years. We've seen pretty good growth of this over the last year or so, but I still think it's massively underutilized. And one of the difficulties with receiving these JSON payloads, if you're a high traffic website and every one of your users is sending you one of these, it's essentially like an extra request on top of every page load as well. So you could realistically be looking at like doubling traffic. And they also have a big JSON payload. So it's not just like a GET request, it's actually a POST request, and here's a big chunk of data as well. So I built Report URI to ingest this JSON, to take these reports. People can have an account, they report to us, and we give them pretty graphs and dashboards. But not just for CSP as well, because CSP is only one of the current reporting APIs built into the browsers. There's actually a whole host of them. There are loads of different things that the browser can tell you about in real time when your website breaks. And I kind of started playing around with these like 2-3 years ago when I started building it. And I was like, this is just really useful. Like you can actually have the browser. It's almost like the browser becomes an active participant in delivering your browsing experience, your website. Rather than just like, here's some HTML, show it to the user, thanks. It's now like, how about you work with me, and when stuff goes wrong, we communicate with each other. So content security policy is a great one. HPKP is very controversial, may actually be going away soon. Anyone heard of certificate transparency? Show of hands. This is super low every time I ask this question. Certificate transparency compliance came out in Chromium like 2 months ago now. All websites in the world are required to be CT qualified, as we call them, in order for them to work in Google Chrome. But hardly anyone that I meet has heard of it. And the CT reporting mechanism is if a user connects to your website and the Chrome browser determines that you're not qualified and refuses to load your website, you can ask it to tell you that and say, hey, by the way, I just came to your website, but I refuse to load it because according to my perspective, you're not CT qualified. So most people are, and it's not a huge issue. It's just that we seem to have had this global deployment of a compliance requirement and not many people know about it. It kind of like snuck by under the radar. The XSS auditor I just touched on as well. If the browser detects a cross-site scripting attack and is taking preventative measures to protect one of your users, do we not want to know about that? And it's kind of like we do, really. You know, if the browser is literally getting to the point where it's stepping in to save your user, you should probably have it tell you that it did that because you've got something wrong. And then the last one as well, OCSP stapling. I'm looking forward to Mark's talk this afternoon because he's going to touch on revocation, which this is linked to. Is Mark in here? What time is it? 3 till 4?
I think so.
3 till 4, yeah. So this is a revocation checking mechanism for certificates if you have HTTPS on your website. And you can, again, ask the browser to know if you're doing all of the things right. Is the user going to see error messages on my site? Are they going to refuse to even load my site? Tell me if these things happen. So I built Report URI to support all of these things, and I built it kind of 3.5 years ago now. It was about 4 years ago when I actually started building it. I launched the first version 3.5 years ago, and it was literally just me. I literally just like sat down with an empty like text editor one day and had nothing. And I was like, oh, it's just JSON. So I just write a couple of scripts, post the JSON payload into the endpoint, and the script will just parse out the JSON and shove it in a database. This will be really easy. That was the worst idea ever. So for sins in my previous life, I'm a PHP developer, so all of my application code runs on what DigitalOcean call droplets, which are their virtual servers. So I've got a whole fleet right now of, they're just like a pretty vanilla Ubuntu and Nginx stack running PHP 7.2. So they're all hosted in DigitalOcean. So hosting the application itself isn't too hard, it's just kind of like we need more CPUs and RAM as the load goes up. The real problem for me was the database side of things, because I'm not a database guy. I don't have any experience with databases, and I really didn't want to become a DBA either. It was not high on my priority list. So I used table storage in Azure as the back end. And a lot of people are kind of like, this is really weird. You've got your application code over here and storage over here. But table storage just really worked very well. It's just a basic JSON key value store. You put something in with a key, and you can pull it back out with a key. And they do all the scaling, all the management, all the routing of traffic, everything. So for us, we still use this today. It was still the best choice. So application code resides in DigitalOcean, speaks to the database via a simple API into Azure. Now, the first month that I started Report URI, it was literally just me using it, because I was going to build it for just myself, and I thought, I'll just stick a web UI on the front, and anyone can use it. So it was a free project, open for... That was coming. I'll just reload while I carry on talking. So, the good thing that I wanted to do is that I wanted to make sure it would be properly scalable. Because I was like, well, I'm using it, and then a couple of my friends will use it next week, and then, you know, maybe a few more people will actually use this. So, but it's built in the cloud, right? So you build an application in the cloud, and you can literally just add more cloud. It's like, we need more reports, we need more whatever. We'll literally just add more cloud. So you can just dial the cloud button up to 11 from more resources at this thing. So Report URI did start to grow, and this was the thing that I really didn't expect. I'm going to fully reload just in case. This was the thing with Report URI that I didn't really expect, was that people actually started using it. And it's like, I built this project, I put it out there. Yes, it's kind of, I thought it filled a genuine purpose and that it was really useful. But it did surprise me when people started using this. And people started using this at scale. Now, I wrote this talk like 3 months ago, and I used current figures from 3 months ago. And from the very first month that we started to the first time I delivered this talk 3 months ago, we've actually done times 2 million on our monthly load. So we did a little over 10,000 reports in our first month. And as of the statistics about 3 months ago, we're now doing about 16,000 reports a second. So, like, I'm about to tell the scaling story now of how we went through that, because we literally did go from 10,000 reports, it's like 10,800 in our first month. And last month we had peaks around averaging about 16,000 per second. So that's 16,000 JSON payloads arriving at our edge nodes every single second that we have to do something with. And you can't just dial the cloud up to 11 to cope with that, because if you dial it up to 11, your cost goes up to 11 as well. So we've had to become more efficient. We've had to become a lot better at processing this. So kind of very first scenarios, this is essentially what would happen. we'd have our customers, they deploy us onto their site, and all of their browsers would send reports to us. So if you go to, like, you know, there's different banks and stuff like that, but let's say you go to Amazon. They don't use us, but let's say Amazon did. You go to Amazon, something happens on Amazon's site, it goes wrong. Your browser would send the report to us, and it would hit our application servers. We then do, like, filtering. We hold the reports to a really strict schema. We use our kind of bird's eye view to look at things that are kind of spammy, or maybe you don't want to see, so we do some filtering as well. But essentially, when reports hit us, we have to do all of this processing and then store them into the database, into your account. So at this point in time, because of how Azure works as well, because it's a simple key value store, we were actually doing a lot of database transactions for a single report. So a single report would come in and hit our application servers. Now, all of our application servers are truly ephemeral. They have no state, they have no anything. So the first thing it would do is it would fetch the user entity from Azure. The user entity is essentially just their row in the database, because that would contain, one, whether or not they actually had an account. Is this being sent to a real account? What filter settings does this user have? Because we have customizable filters. So we had to do the request into Azure to get the user entity back. Then we actually denormalize data on the way in. Now, typical RDBMS people are going to be kind of like, what are you doing? But we actually store the reports in 4 different time slices. So we denormalize them on the way in. We store one in the hour, the day, the week, and the month for easy querying later. And that'll become clear why. So we had to do 4 inserts into the database as well for each of the time slices. Now, we can't just do an insert because Azure Table Storage doesn't have an increment feature. So we can't just say, here's a report, increment it. So we actually have to fetch the count out, increment the count, and then put it back. So it's actually 8 requests into the database per inbound report, plus the original one for the user entity. That meant that for every report that was coming in, we were doing 9 transactions into the database to store it, on top of the application processing. Now, this wasn't a problem at first. It sounds really bad, and I'll tell you how we made this better as we go through. But one of the reasons that I chose table storage for the database was their transaction cost into the database, right? It's 0.00036 of a cent for 10,000 transactions. So this is pretty cheap. And at the first month, I'm doing literally like 10,000 reports multiplied by the 9. It's like 90,000 of these. No one cares, right? It's like literally about 8 cents or something. And I was like, that's fine. But now we're doing 16,000 reports a second. And that's just never scaled along the way. So we have had to think of things that I've never had to think of and solve problems that we've never had before. And the first and obvious thing was to have some kind of persistent state on our edge nodes. We needed, for these edge nodes, to not have to go to the database every single time for stuff like the user's entity. The user doesn't change their account settings very often, so we can cache these things for like 15 minutes. So we deployed memcached instances onto all of our edge nodes. If they fetch the user entity from table storage to remember their settings and config, we would store that in memcache for 10 minutes. So that theoretically there was only ever a maximum 10-minute window to fully update. The entity would just expire in memcached, and then the server would just grab a fresh copy of the entity. This was like the first and easy, obvious thing, and what that allowed us to do was to go down to 1 to 8 instead. So we weren't constantly going back to table storage to fetch the user entity. This really wasn't enough, though. We needed to do a lot better than this. And it was around about this time that someone signed up to the service. Someone signed up to the service that was exceptionally large. And the problem is, if someone just goes to the website and signs up and starts sending us reports, we just start getting traffic. There's no like process. It's like, hey, we signed up. Here's all of our CSPs. Like, pow. And we say DDoS. I usually refer to it as an accidental DDoS. A very, very, very large website came online and started sending us data at a rate that we just simply could not handle. And this was like a serious incident for us. This took us down for about 2/3 of the day. It was like probably one of the worst times ever. But we were accidentally DDoS. And I've actually written this story up. If you do want more information on this, because one of the things that came out of this as well, we were looking at how you might be able to use these features in a hostile fashion if you wanted to turn the browser into like a post cannon and use it to just hose a website with data as well. So we were on the receiving end of this. The company was actually really good about this. They let me use their name and everything and tell people who they were in the blog post. So they were actually really good. They worked with us to resolve this. But essentially the problem was CSP and all of these kinds of reports are very spiky, because if you're a high traffic website and you've got no problem, and then suddenly you've got a problem, all of a sudden all of your visitors start sending us these massive JSON payloads like that. And then we can go from like nothing to 10 times traffic in a second. And this is essentially what happened. So back then I was using New Relic monitoring. This is actually our New Relic monitoring dashboard. And we weren't doing too bad back then. We had 2 load balancers sat in front of our application servers, and they started hitting like 8,000-9,000 requests a second. The application starts to scale. Added the new load balancer. This one hadn't quite propagated in DNS yet, so it wasn't getting any traffic. But by the time it had propagated in DNS and was getting traffic, the ramp had already continued. So the new load balancer came online, and it's like, yep, okay, time to scale again because we're still overloaded. And then the new load balancer came online after that, propagated in DNS. And I'm just sat there watching because I get all of these alerts on my phone, and it's like CPU 100%, RAM 100%, network throughput 100%. I'm like, crap. And it literally just wasn't scaling fast enough. And the problem was, I was literally sat watching this the day it was happening, and I'm like, there's really not much point, right? Because our load balancers can maybe handle like 5,000-6,000 requests a second a piece. And I'm like, damn, by the time the 4th one had propagated and hadn't even fully propagated yet, we're hitting like 30-40 odd thousand requests a second on each one of our load balancers. And I was like, and the service is still free at this point. It's still not a commercial service. And I was just like, this is just not working. And I wanted to keep scaling it because the website was down and we were being hosed. And I was like, I don't want to be down. Let's keep scaling. But realistically, we couldn't keep scaling because eventually when that 4th load balancer did propagate in DNS, we were literally doing an average of like 40,000 requests per second per load balancer. And just to put that into perspective, we were topping out because even our New Relic monitoring agents on the servers crashed. We were topping out about 700 megabits per second inbound per load balancer. So that was like 2.9 gigabits of inbound JSON, which is like sticking your face in front of a fire hose and opening your mouth to take a drink. So the problem was, I was just like, oh my God, crap, what do we do with this? Like, how do you deal with this, right? Like, you're sat there, you're a single person running a side project that's now getting almost 3 gigabits of inbound JSON. And I'm like, what do I do? Do I just keep scaling? Do I just null root everything in DNS and wait till it's over? Do I throw more cloud at this? Unfortunately, I didn't have to make the decision because my hosting provider dropped me because we were starting to negatively. So when your hosting provider emails you to tell you that they're going to kill you off their service, and your hosting provider is literally like a cloud scale hosting provider, I was like, oh shit, I'm so fired. This is not good. So whilst all of this was happening, DigitalOcean were trying to mitigate what they thought was a legitimate DDoS attack because all of these reports are essentially coming from unique IP addresses. So to them, it literally just looks like a full-on, like you're getting hosed with 3 gigabits DDoS. So they dropped our IPs and essentially they killed our IP addresses at their edge. So they actually just stopped routing our traffic internally in their network. And when your hosting provider stops routing traffic for your IP addresses, you should start looking for another hosting provider because they're not going to be very nice to you afterwards. But actually they were. I got in touch with them. They had a really good chat with me on the support ticket system. I explained what was happening and that it wasn't hostile and that we were trying to work to get this resolved as fast as possible. And I still host with DigitalOcean. They didn't get too mad. But one of the problems that we had was we couldn't get rid of the traffic. Like, we could ask the people at the other side, like, hey, please stop sending us all this traffic. But ultimately, we needed a way to deal with that faster. And this is one of the biggest threats to our service was if you think about it, if you deploy a policy onto your site and you use something like a CSP, and this is like one of the hostile use cases we thought, you set a content security policy on your site and say, by default, you're not allowed any content. And then you've got like 20 pieces of JavaScript, 20 style sheets, 30 images, all of this other stuff. The browser will send a single report for every single one of those violations of the policy. And what you can actually do is get the browser to generate 50, 60, 70, 80 or more post requests per page load on your site. And every single one of those post requests has a JSON payload at the bottom. And I was like, damn, you could literally, like with a really low traffic website, you could generally like get maybe a megabit a second of outbound from a client by using a hostile CSP. And then you can set the reporting endpoint to whatever website you don't like. Now, this one was accidental. This is what Envato, the company that did this, they essentially did this by accident. Very simple misconfiguration in their policy. And they essentially firehosed us with almost 3 gigabits of traffic. So one of the problems that we had was the way that we structured our reporting addresses as well. So we have our domain on reporturi.com, and we have our standard web app. We've got the account, home, login, tools, our actual homepage. And then if you were posting as a report, we had the /report endpoint, and you put what we call your report token. So when you sign up, you can pick like a pretty report token. So you send it to /report/Scott Helme in my case. Now the problem with this is all of the traffic hits the same host name, and therefore the same IP addresses. If you want to load the homepage, you resolve this domain. If you want to send a report, you resolve this domain. And they all go to the same set of IPs, and thus all the traffic hits the same servers. We had no way of segregating this out. So the reason our website was suffering is because our website is the same place that all of the reports were being sent. And we couldn't break that infrastructure apart. And this was probably one of the biggest things, and hopefully this might be useful to someone else, because this was like a major light bulb moment for us. We need to be able to route our traffic differently, and we need to be able to route it a lot earlier, because we need to control this traffic before it hits us. Once it's hit us, it's too late. Even if we just drop all that JSON, simply receiving it is too much. So we needed to be able to throw it away a lot sooner. And this is what we did. We literally moved the report token into the subdomain, because now all of our web traffic will still hit reporturi.com, but by taking the report token and putting it in the subdomain, we just have a wildcard subdomain that resolves to our reporting infrastructure, and anyone can pick any subdomain that they want, and it doesn't matter. So what it allowed us to do, though, was if we now have a problem and someone is being super hostile, we can have our IP addresses for our web application. That's our wildcard for all of the infrastructure. And then if someone's being hostile, we just do this to them. If someone's hurting our service, we just do this. If someone is, whatever's happened, we don't actually care. But if you're sending us too much traffic and it's impacting our service, we can just now null route your subdomain or send it somewhere else to different infrastructure. But the point is we can get it off our infrastructure if we want to. And most importantly, we can get it off our application servers. Because now if someone fire hoses us again like that, accidental or intentional, it will never impact our web application. So we can be getting hit with like 50 gigabits of traffic and all of our ingestion servers can be on fire, but the web app will still load just fine because it's running on its own infrastructure. And that separation of interest was like the big thing for us, was like, why are we sending them all to the same IP address? We need to break the traffic apart. And it gives us more flexibility because now, especially with GDPR and stuff like that recently as well, and people that have like European hosting and processing requirements, we can now just resolve subdomains to different IP address groups in different regions. So we have a region in America, a region in Europe, in Amsterdam. So if people say, hey, our reports have to be like stored and processed in Europe, it's like, fine, we'll just point your subdomain to Europe. You know, this gave us so much more flexibility and so much more control over our traffic. And it was, in hindsight, it's super obvious, but we just didn't think of this in the beginning. So hopefully that will be helpful to someone to give you more control at DNS. But the problem that we still had on top of all this was just the sheer volume. Because whilst all this was happening, we were still on our kind of traditional infrastructure, kind of like this one. And one of the things that came from this, I said before, we stored it in 4 time slices when we store the reports. In the hour, the day, the week, and the month, we decided to drop one of the time slices because traffic was still ramping up just generally outside of the DDoS. Traffic was going up month on month, and it has every month forever. So we're like, look, we're going to drop one of the time slices. So you're only going to be able to query on the hour, the day, or the month. You won't be able to query on a week. So we could drop 2 time slices. That got us down to a 1-to-6 ratio. But it was still too much because at this point, we're literally doing millions of reports a month. So millions of reports come in. We're doing many millions of transactions into the database as a result. So we needed to go further because the service was still free. I wanted to keep it free, but it had to become more cost efficient while still doing exactly what it does now. So we decided to try and use Redis. And we actually run a pretty massive Redis instance right now. It's got like a bazillion cores and however many gigabytes of RAM. It's crazy. And it sits in between the kind of the whole processing. So the browser sent the reports to our ingestion servers now. Our ingestion servers do the basic kind of filtering, pre-processing, check the schema, any custom user filtering and stuff like that. Except now they insert it into Redis. And what we do in Redis is we have a 10-second buffer time in Redis. So all of the ingestion servers will just shove everything into Redis for 10 seconds. And what this allows us to do is deduplicate reports. So if you've got a problem on your website and all 1 million of your visitors every 10 seconds send us the same report, we get 1 million of the same report from your 1 million visitors. And historically, we would have done 1 million inserts into the database. Now, in that 10-second window, we can just stack that report in Redis once with a count of 1 million. And then behind that, we have the consumers. We have a fleet of 6 consumers, and each consumer takes it in turn every 10 seconds to pull out the contents of Redis and then start inserting them into the database. So now those 1 million reports that you sent us are actually just a single insert with a count of 1 million rather than 1 million inserts. So this allowed us to massively, massively deduplicate our inbound traffic. Now that Redis instance is expensive. It's got a shitload of processors and a shitload of RAM. But the cost offset against the database was worth it. This was a financially viable solution to the problem. And it made a massive impact. because with that deduplication now, we could literally get a single report on the inbound down to just 0.01 transactions against the database on average. So to go from 1 to 6 to 1 to 0.01 was a massive saving for us because our transactions and our database interactions were our biggest cost. And again, this is still a side project. I was literally still just paying for this myself and running this service. But at this point, it became like a challenge. And I was like, no, I will not be beaten. I will make this thing work. So I was like, this is really good. And the traffic just kept scaling, right? We've seen 20, 30% growth month on month, every single month since I started this thing in terms of our traffic volume. And it just kept going. So we needed to push it to the edge. And this is both in both phrases, both senses of the phrase. We really needed to push it to the absolute bleeding edge, but we also needed to push it out to the edge. We needed a CDN provider to come and help us with this now because we were dealing with significant quantities of traffic that we were just not built to to cope with, basically. So we brought on board a CDN, and I currently work with Cloudflare using many of their features actually to help us out. And it's not just a CDN in the traditional sense of the word. They do sit in between the browser and our ingestion service. So all of our traffic naturally routes through them. They do kind of their basic hostile traffic scrubbing, DDoS mitigation and things like that. So they do all of like the traditional CDN things. But one of the other things that Cloudflare allow you to do is that you can actually deploy code on their CDN. So they have something called Cloudflare Workers. You can essentially write against the Service Workers API in JavaScript, deploy code to their edge and have that code executed on inbound requests. So they're not just like a blind CDN just blindly proxying reports for us now. They are actually now an active participant in us ingesting reports. So all of the logic that we've had on our servers, doing schema validation, formatting, removing duff data, all of that kind of stuff, we shoved it up to our CDN's edge nodes. So if we were going to filter a report previously, it would still hit us, we'd still process it. Whereas now, if we're going to filter it and throw it away, it literally stops at Cloudflare's edge, and it doesn't even hit our servers on the inbound side. So they throw away bad reports, they deduplicate and stack for us, they do everything else now. So we're now executing our code on their edge instead of on our edge, where it costs us more money. And this was a really big thing for us because one of the biggest things that we commercialized last year. I took investment and launched the commercial service in November, and people now have a quota. So you come along, you subscribe, you get your account, and you get X thousand million reports per month or whatever. And people have a tendency to kind of blow through their quota. Now, once you blow through your quota, we stop processing reports for you. But that doesn't mean that people stop sending them, right? So we're still getting hit with, we have customers that buy like 50 million report a month quota, and they literally smoke it by like the 4th of the month. So they're sending us like 10 million reports a day. But then they'll still send 10 million reports a day for the rest of the month. Now, yes, we're doing less processing on them because we can discard them, but we're still getting them. We still pay for the bandwidth, we still pay to process them. One of the really good things that we do now is with Cloudflare's Edge, we can, as soon as they hit their quota, we call into the Cloudflare API and say, drop traffic to this subdomain. We don't want it anymore. They're over the quota, we'll reset it on the 1 minute past midnight on the 1st of the month, but just drop the traffic and don't let it hit us. And that for us has been one of the biggest cost-saving things, is not getting traffic that we were literally just going to throw away anyway. Because we get millions of these things. And I can show you some traffic graphs in the Q&A at the end, where literally, like on the 1st of the month, when everyone rolls their fresh quota, we can literally do like a 37 times increase in traffic once everyone now gets report ingestion back. And we literally have these graphs where it's like, oh, there's the 1st of the month, and it just flatlines the rest of the month because it's insignificant. So pushing our code further out to the edge and closer to the browser as well, because Cloudflare have 150 data centers around the world or whatever. They're doing that processing. If we're here in Sheffield, it's probably going to like London or Edinburgh or something, rather than our origin servers, which are in San Francisco. So it's less resources consumed on the browser because it can make a local connection for local processing and then terminate that as well. It's just better all round. It gave us a lot of freedom, a lot of flexibility. So that's kind of the story of how we got to where we are, which right now on average is something like this. We are currently only doing 0.006 something transactions into the database per inbound report now. And this is what has allowed us to make the commercial service even viable. Because without this, it would just be like cost prohibitive, basically. So I did have to commercialize it last year. It was started as a free project, and I ran it for a free project as long as I could. But it literally got to the point last year where it was costing me so much money, and I'm sure you all have side projects like this and a wife or a partner behind you that's like, why are we spending so much money on this thing? And I was like, look, I have to turn this off or I have to start charging money for it. Because it got to the point when it was like, this is not a side project anymore, right? The budgets and the money that I was spending was just not side project material. So we commercialized it. It is now, we do have a free plan up to 10,000 reports a month because I still wanted people to be able to use it for the value that it gave, which is why I started it in the first place. So we have a good free tier to get people going because the purpose was to help people, to make this technology available. It was never built to be a commercial business. It was never built to be a subscription-based service. But for the, basically there was no other way. So this is where we are today. This is the current kind of infrastructure that we have. Browsers send in the report. We do most of our pre-processing now in Cloudflare, hits our ingestion servers into Redis, and then every 10 seconds the consumers will flush Redis and process all of that data into Azure. So that's our current infrastructure as it stands today. And on average now, we're breaking through 10 billion reports a month quite comfortably. So we are literally receiving, I think this month we're on track to be like 10.8, 10.9 billion JSON payloads ingested in 3 years when our first month was 10,000. So it's come a long way. I'm sure it's still got a long way to go. And I'm sure there's probably people here that can offer advice on this and tell us where we're going wrong and what we can do better. But that's our current infrastructure as it stands today. So I want to kind of change the pace a little bit now and talk about what that's allowed us to do as well, because that's how we've dealt with the technical challenges to get to where we are and process this much traffic. But the service growing to the size that it has put us in a position where we started realizing things, and we started realizing that we could make certain observations about the state of security. And one of the things that really interested me was how can we use all of the data that we have to do more good? So everyone that is a customer gets their reports, and that's helpful to them, right? Oh, we've got a problem on this page, or we've got cross-site scripting over here, whatever. That's super useful to them as an individual. But we can look at the aggregate data, and we've literally got terabytes on disk now. And it's like, what can we extract from that as a bird's eye view? How can we as the service provider look down on all of that data, and can we get more value from that? Rather than just delivering the service to our one customer, is there something we can do? And it turns out that there was. Now, one of the things that we get is we literally get reports from all over the world. On an average month, we can see about 80 million different unique clients sending us reports. So that's a pretty large data set from essentially quite literally all around the world. And early on, I built some spam filtering into the service because it's literally just an open endpoint on the internet that accepts JSON data and processes it into the database with no authentication or anything, right? It's just like spam me. So we had to build spam filtering really early on. And the spam filters triggered one day, and they were like, oh, we've got these reports coming in, multiple different sites, multiple different clients all around the world, but they're all essentially the same report. And I was like, that's classic spam filter for what we had at the time. And it literally just looks like all of these endpoints all around the world are just sending us the same report, but claiming that it came from different websites. And it was like, all of these websites all suddenly have exactly the same problem at the exact same moment in time. Nope, toss those away. But I always make sure to review them. And I was reviewing them, and the reports that were coming in, they were kind of like this crazy Russian domain. It was literally just like randomletters.ru. So I was looking at this, and I was like, well, honestly, it was Russian. So I was just like, there's probably something funny going on here. I'll investigate this a little bit more. Maybe I shouldn't say that. But I was like, crazy random letters and numbers.ru. I was like, I'll take a look at this and see what's going on. So I started looking into it, and they were all saying that all of these different websites were all blocking a piece of JavaScript on this domain, and then it had the path for the JavaScript file, as you saw. So I went and got the copy of the JavaScript file, ran it through like a JS Beautify, and then started reading through it. And I was like, no, this is like properly written code. It looks like a genuine report. It's just that all of these websites have all suddenly got this JavaScript on their page. And I was like, unless someone's just gone out there and found cross-site scripting in like hundreds and hundreds of websites and put this exact script file on, it was like 340 different websites. I was like, really? Is someone just gone on a hacking spree and got like persistent cross-site scripting in these 300 and odd different websites? It seems really odd. And I kept reading through the source, and I eventually came across a variable. And the variable was a reference to a Chromium extension ID. And what had transpired was it wasn't actually that all the websites had been compromised and had the script on them. A browser extension had gone rogue and was inserting the script onto all of the pages that people who had it installed were visiting. So with this traditional view was always like CSP looks at the content on the page, and the content on the page comes from the server. And it's like, well, hang on a minute, not necessarily, because Chrome extensions, browser extensions can put content into the page on the client side. And this was like a real kind of change in thought pattern, in that this now wasn't that the page was compromised and the page had the script tag in it. It was the browser extension on the client side inserting the script tag. And this is why we were seeing it on so many different websites. Because if those people went to like 5 websites that were our customer, they would get the exact same 5 reports on those 5 websites. So I got in touch with the Chromium team, and I know a few people that work there because I closely integrate with the Chromium APIs. And I was like, look, I think we found what is a hostile browser extension. This browser extension has just released an update, and the update has now got a new thing in the bottom that's just adding a script tag to every single page that it can. And it's a super dodgy script tag. This is really hostile. And they were looking into this, and essentially it was like, you've now got this rogue browser extension, and they can do whatever they want, include inject anything into the page, which is what it was doing. And it was injecting malware into the page. So the Chrome team, they passed this along and they actually dropped the extension from the extension store. This extension is now gone. And the weird thing for me was that we found that first. And I was like, this thing that we built that wasn't supposed to do what it just did has identified a malicious browser extension because of the things it was injecting into the page in violation of the policies. And now, an individual site operator might not be able to kind of ascertain that just from their reports, because it's like, oh, we've got some crazy Russian JavaScript thing, take a look at the page, there's nothing there, it must be erroneous. But as a service provider, when we can see hundreds of different websites all suddenly reporting this, we can leverage that position to try and make more out of the data, because the data in aggregate tells us different things. So, like, we used to call this the spam filter, we now call it our threat intelligence feed. Because I was like, shit, that sounds loads better. So we now actually have a threat intelligence feed. It's super cheesy, I know, but I was just like, no, we totally need to rename this thing now. So we now actually have a threat intelligence feed that people can subscribe to, and we use for providing data like this on rogue extensions and kind of like widespread attacks. And you can sell the threat intelligence feed for a lot more than a spam filter. So the other thing as well was to kind of take this onto the next step. Is we also actually use this to detect malware as well. Actually malware installed on an endpoint. So a really big customer of ours, a very big news agency in America, got in touch with us and like, look, we've pretty much nailed most of our CSP issues. We found a couple of things, but we keep getting these reports through and we just cannot make any sense of these reports, but they keep coming reliably. So they sent me a few of the JSON payloads, and they have their own intranet site that only staff physically inside the organization or VPN to the internal network could access. So if you're accessing this intranet site, you're literally on the local network. And they were like, every time we get these reports saying people have gone to our intranet site to this page, and again, there's like this script source has been violated, and we're trying to load stuff from this crazy Russian domain. And the first time we started getting these, we were like, oh my God, major incident, quick check the intranet site, someone's like hacked it. And they said, look, we've been through everything and we cannot find any trace of this JavaScript file that it keeps telling us is there on any of our pages. So I looked into this for a bit. Again, I went and grabbed the actual JavaScript file and had a look at this. And I was like, no, it's looking at what this is doing. Again, I was kind of like, maybe this is a similar thing to the browser extension. Maybe there's something hostile on there. And what it actually transpired was this was actually malware. So I did some research on what the file was and the code inside it and identified the actual piece of malware that would be injecting this. And it was kind of like malvertising. Doing, you get onto the endpoint, it starts proxying traffic, and then it's just trying to inject like paid ads or malicious redirects into web traffic. So every time they were going to their intranet site and this malware was injecting its like bootstrap JavaScript file, it would fire a report and say, hey, we've got crazy Russian JavaScript on our page. I was like, so this isn't on the application. You don't need to be looking on the intranet server on your application. You need to be looking on the client, because you've got clients in your network somewhere with this malware installed. So when they browse to your intranet site, it's injecting the JavaScript into your intranet site. And it was like, oh wow, we've been looking at this totally the wrong way round. So they had a pretty locked down environment, and it was easy for them to identify internal endpoints that had local admin for legacy applications, the traditional kind of problem that we come across all the time. People with local admin for legacy apps had installed things, and they had malware on a few of their internal endpoints that were doing this. Now, they had like 9,500 internal endpoints. It was a pretty difficult thing for them. And we were looking to see if there was some kind of way that they could inject random tokens into the URLs to then check those against their server logs to look for the IP of the internal client. Everyone follow that? It's kind of a complicated solution, because CSP reports don't allow us to identify the endpoint that sent this, and they're not supposed to. But if they put a random token into that URL, when they loaded that page, they could check the application log for the random token and then look at the IP for the internal client to identify it. So this was like a super hacky way around this. We didn't quite get to fully deploying that because in the end, they managed to, by looking at the websites on the internet the person was going to, they were able to guess what department they were in, and they went and found the endpoint and sorted this out. But we'd actually identified an endpoint, so it wasn't on the server, because people think, oh, we've got script on our page. Look at the application, look at the server. But it's not, it was the client, because it was running malware that was injecting stuff. So that's just a couple of the interesting things that we've done. I'm going to write up a blog post, so one that I'm dealing with right now. Very kind of similar thing on something that we've identified by using these reports at the volume that we have them. Because, you know, if we can take this data, and yes, we're serving our customers, etc., but if we can take this data and actually make more use of it in aggregate, in total, and again, there may be people here that have listened to this and thought of something that we've not yet thought of. What can we do with this data? And this is probably an open question, really. You know, like if there's something that you think that we can do with this, I built this project and this product to be helpful. That's why it was free for so long. And that's why I want to try and do more cool stuff like this with it. Because we still have a long way to go in securing the web. So thank you very much. I've left plenty of time for questions. I hope there are some. I've got literally 10 minutes of the Q&A. So yeah, thank you very much. So, are there any questions?
So you talked about at the start of the month, the traffic,
yeah,
and then it flatlined for the rest of the month. For Report Your Eye as a business, would it not make more sense to sort of, if people are like subscribing to like one quota and then just completely like misjudging it, would it not make more sense to charge them as they use their quota, so to speak? So like if they go over, you say that's fine.
Oh, okay, so what? So do you mean have their billing cycle not run per calendar month?
Not run per calendar month, but run by usage, or like say even have like not let them completely run over and say, yeah, you owe us $8,000 for this, but like even like a bit more, or like.
So we did think about not running. We did think about not running the billing cycles per month, and then people would come in and out of quota at random points through the month. That was just harder with our payment provider, so we didn't, because it would have required a lot more logic in the code. Because of the CDN as well, we can absorb that spike quite well now. We always have to massively over provision, because if a new customer comes on board and triples our load like that, we need to soak that up. So there's literally, you can literally see our graphs are on here. So that's our infrastructure. This is all per week, so we're doing like 2.6 billion requests, 1.2 terabytes of bandwidth, yada yada yada, and then you can see, you can literally see when our month rolls, which is there. It's like, welcome to the 1st of July. And then you can see all of the people that literally smoke their quota in like 6 hours, because we just hammer them right back down. So every time the quota rolls, we literally do see that every single month.
On the same comment, actually. So what about doing things like, for example, some SAA products too? So it's like, you pay this much, we will process the first 500 requests we get from you every second, or something like that.
Yeah. So kind of like the question there was like, why don't we give them like a quoted throughput, and we take like the first 500 a second and throw the rest after that? We could do that, but then they would be getting reports all month and not run out on the 4th or 5th of July and then upgrade their quota. We'd essentially be downsampling for them while still paying all of the costs. So that would make the subscription a lot more expensive, and it wouldn't be viable. For us to keep the prices where they are, and still provide the service, this is the most efficient way to do it. So yes, there is the cost attribute, and people are like, oh, you just banhammer them and force them to upgrade. And it's like, well, yeah, there is that aspect, but it's also that if we did it the other way, it would naturally make the subscription a lot more expensive anyway. So one way or the other, they would still pay, whereas at least this way, it's a lot more transparent. Any more questions? Yes?
You get a spike which starts from different customers. Are you finding that each month it's the same customers, the same issues, and you're just not fixing problems?
So we only work closely, like very few of our customers actually have the enterprise plans which come with consultancy. So most of them are just like whack a credit card in the website and we'll send you JSON. But we do work very closely with quite a few of our larger customers, and they I guess they're on the enterprise plans with consultancy because they want to fix them. So, we do. It's kind of weird because we have these blips where like new people come on and they get stuff in order, but we're always trending up. So it gets muddled in with the data a lot. It's hard to single out individual customers. But our number of new customers is accelerating faster than the number of new reports. So someone somewhere is doing this right and actually reducing reports at the same time. Any more questions? Yes.
Yeah, just out of curiosity, what kind of payload was the browser plugin that you detected using? Like, how lucrative do you think that was? Like, who's, obviously you put on someone's picnic.
The Russians haven't come for me yet. The Chrome extension one, I didn't really spend as much time as the malware one. Once I got to the point where it was like pulling in JavaScript files that were flagged as malicious in like multiple online scanners. And at that point I was like, I'm just going to report this. So the first time round, it was kind of like the first time we'd done this and I didn't really know where we could take it. Now we get a lot more involved in figuring out what they are, what they do, reporting them. That was literally the first ever incident. So it was I was new to this and we could have probably done a lot more with that.
So what do you usually find then when you have browser extensions?
It's either malvertising or crypto mining right now are the two big things that we see. Right. We see a lot of coin hive in our reports as well, particularly. Yeah.
With regards to sort of the threat intelligence you're using, is this something someone can subscribe to? Do they have to pay to subscribe to it? Or?
Yeah, so, and again, it's kind of one of these things, right, where I'd love to just make the feed available and free, but I imagine the amount of people jumping on that would crucify us financially. So it's not expensive. Companies can subscribe to this and get the feed. It's obviously all completely anonymized because it's only the stuff that we're blocking. No one ever gets any data on who our customers are, what they are, their customers, anything like that. So it's literally just like, hey, we've just started blocking this new JavaScript file all of a sudden coming from this crazy Russian domain. Maybe that's useful to you or not. But yeah, get in touch if you're interested. It's, like I say, we want it to be helpful, but it's also got to sustain itself in terms of its costs. So we have to charge something for it. Does anyone have any ideas? Anything that popped into mind? Like, is there anything more that we could do with this? I want to ask you a question. Like, have you thought of anything where this could be more useful?
Maybe not directly for this, but one of my colleagues is doing the internal service. So we take a cut of our build for the web app every night and do automated testing against it. We build in an endpoint so we can automatically detect if we find, say, cross-site scripting bugs, using the report URI capability to tell us whether the payloads are fired or not. It's the most efficient way of telling via an automated nightly process.
Okay, so yeah, starting to move it more, because we already do a lot of work with, like people generally report with us on their test and pre-prod environments, but like one of the most common things we find is like pre-prod or test assets slipping into production because they're not whitelisted, but it's an interesting spin to see if we could integrate it into like a security process as well. And then, so I guess you would just attack the application, see if you can find cross-site scripting and then trip the policy and use the CSP report as the indicator.
Exactly what we're doing.
Oh, that's nice. That's a good idea.
It's not fully built yet.
Any other inputs?
So when you talked about how it was used to find malware in on the internal internet, and you said, "Oh no, but we can't detect individual endpoints." Is that something you're looking to extend into? Because like with this sort of threat intelligence thing you've got, surely that would be a valuable tool to be able to say to kind of like bigger enterprises, like, oh yeah, this endpoint here.
Yeah, so this was a big thing for us. The question there was essentially, can we do more around identifying internal endpoints, especially if it's an enterprise like this one was with like 9,000 clients. Within the actual scope of CSP and the other reporting mechanisms and how they work, there's no way built in to do that. We see their IP address, their public one IP, so if they've got 9,000 people behind that, that's no use, and we get their browser UA string because it's a HTTP post, which is also no use at all. Which is why we tried to come up with like the crazy, can we insert random tokens into the URL idea? That was just trying to hack around the problem to help them. We don't really want to do that either in terms of being able to identify individual clients because they're not our visitors, they're our customers' visitors. And we've never, one of the most common feature requests is like IP addresses. We never store, log, or process them, which made GDPR super easy for us. We don't store the browser's UA string. We basically want as little information about our customers' visitors as possible. So we literally just take the JSON payload and we sanitize that as well to make sure there's nothing. It is, and we're really fortunate. The service was built by me. It was like a security focus, and the 2 people that have joined had a security focus. So we're really fortunate that everyone's had like a security focus with them. Like I say, especially with GDPR, because it was like, oh my god, that if we were storing like everything and IPs and UAs and all this stuff, that could have been a nightmare. But we actually just store the raw JSON that's been sanitized. Any other questions or ideas? Last one. Oops, sorry. We'll do 2. Go on.
So is this side project now your like full-time job, or how much time does it take?
It's almost full-time. With our infrastructure costs and the other couple of people that I brought on, because I brought on a proper developer. I'm not what I would call a proper developer. So I brought on a proper developer to work on this Czech guy called Michal Spacek. He's super awesome. In fact, you can see all my code review tabs open on GitHub at the top, because he's like checking in and doing PRs faster than I can review them and pull them. So I brought excellent GIF right there at the top of Twitter. So my tethering's not working indoors at all. But yeah, no, I brought him on. He pays me like a fraction of an income. I also do like training, public speaking, and a few other bits as well. One, just to keep it interesting and keep things like diverse. But my hope is that one day it will be like it will be able to pay everyone a proper salary and be a fully profitable business is my goal. And there was one more down here somewhere.
Would there be, because where I come from, again, I work somewhere with quite a big internal network that needs to be kept very secure. Mm-hmm. And I was wondering more about the possibility of, would there be some, said about would browser extensions could insert tags, whether there'd be some way of us inserting something like a CSP tag for the malware detection side of things. So anyone visiting a site through our internal network, if there's a piece of malware that's trying to run on any site they visit, that there'd be some way of us picking that up.
You could do that. So the question there was, can we deploy CSP onto other websites that our endpoints visit? And the answer is yes. If you had like something at your edge, an F5 proxy, whatever, you could insert and enable a CSP on all sites and ask that CSP to report to you. So yeah, there's no reason you couldn't do that. If you've got proxying capabilities for endpoints in your organization, that's absolutely possible.
And how would that work in terms of, would that break CSP reporting that they were already doing on that site, or would it work alongside it?
No, because you can have multiple CSP policies present, so they would report individually on both policies if you inserted alongside theirs rather than neutralize theirs. Right, that's lunch. I don't want to keep everyone. Thank you all for coming.